Okay. So you see these people, they have a problem. They are very religious. Well, that's not their problem, that's their choice. Their problem is they cannot use phones because their rabbi told them that there is porn on cell phones. And porn is bad, at least in their view. My name is Assaf Nativ. I'm very happy and proud to be presenting here again at this great conference of REcon. It's important to note that REcon is a great conference not because they keep accepting my submission, but even though they keep accepting my submissions. I'm coming here all the way from a quiet and peaceful place called Israel to tell you today about one of my more about one of my more exotic projects that I had during my time as a freelancer. But before we start, just a few very important disclaimers. Most of what presented here was done by me with lots of help of other people. The rest was done only by other people. Second, these days I work for a startup company called Sentinel, which is a great security company, but it has nothing to do with this presentation. And three, I'm not a religious person of any kind. I'm not promoting censorship. And the product shown here is actually bought by people on their own will. I know it's hard to believe that. And they can actually go to the next store and buy a regular phone for less money. The story of this presentation started about 4 years ago when some client contacted me with a request for a project. It described the project as follows. I want you to take a phone and disable its ability to send and receive SMS, take pictures, or do many other kinds of things. So we could sell it for more money. Now, this logic might sound flawed to some of you, but for the common Israeli, it's quite normal to hear people with silly heads say all kinds of silly things. So my answer was, sure, I'll do it. And that's how the journey for making the Kosher Phone started. By the end of this presentation, you would be able to make a kosher firmware for many GSM Nokia phones. You're not going to do so. You're not going to do so mostly because these days there are about the same number of people who make kosher phones and people who buy them. So what's a kosher phone anyhow? A kosher phone is simply a feature phone with less features. And what's a feature phone? A feature phone is the general name for all phones that aren't smartphones. Therefore, they're also known as dumb phones. An average feature phone can perform most of the things from the following list. Well, then what's not kosher about that? Is it the internet connection, the camera? Well, most of it, actually. Converting a feature phone into a kosher one requires disabling of sending and receiving SMS because this is how a booty text is done. MMS because it's used mostly for porn. And FM radio is mostly used for abomination, of course, and GPRS or switching. Well, some people say there's porn on the internet. I don't know anything. I get all my porn over MMS of it, of course. And the camera, so you won't take photos of indecent women or whatever and do things with that. And games are only played while you're supposed to study the Holy Scripture. And don't even get me started about Facebook, WhatsApp, or Twitter. You all know it's not kosher. So in short, if a feature phone is a dumb phone, a kosher one is one that suffers from severe retardation. But we removed so much from it, we had to put something back. So we came up with the Jewish calendar app. Now here are some irrelevant facts about the Jewish calendar. It follows both the moon and the sun every year as either 12 or 13 months. Days of no fixed length, and it's inaccurate by 1 day every 216 years. It's quite strange. Ask any Israeli or Jew who will tell you about it. That seems like a really easy task. It's not like I need to implement anything. I just need to de-implement things. All I have to do is choose a phone, get the company who make it, remove anything that one don't find as kosher, and collect my money. Choosing a target. We needed a phone that is cheap, reliable, and still in mass production. Let's talk about Nokia. As little as Nokia know about smartphones, they know a great deal about feature phones. On the picture, you can see the indestructible phone made from the strongest material in the universe. That's the 3310, of course. Only way to make a new 3310 is with another one, because nothing else can cut it. They use it to cut diamonds, actually. Yeah. Here's a small sample of my private collection of Nokia phones. And just from this sample, you can see that it's hard to choose because there's quite a variety of phones that Nokia makes. Nokia classifies phones by two categories. That goes with the software version, the software series, and the hardware version, the hardware series. The software version is what most of you probably know, and it goes with names such as the S30, S40, S60 Symbian, Symbian version 3. And that's telling us things only about the UI and the developer's API. So it's not important at all. We don't care about that. We're going to hopefully patch that later. So we don't care about the software version whatsoever. As for the hardware, the hardware version goes with names such as DCT, it stands for Digital Core Technology, or BB5 stands for Baseband 5. The DCT is what started the GSM line for Nokia. The first DCT-1 phone was arguably the first phone to support SMS. And up until 2002, all phones were kosher. I guess that people were just more religious at that time. In 2002, Nokia came with the DCT-4 line and its fancy color screen. But not only it had color screen to show off, it had GPRS support as well. And we all know that color screen plus internet equals porn. Not much later, they came up with a bit more expensive line they call BB5, and these days both the DCT-4 and the BB5 are being replaced by new series with names such as Asha, Infineon X Gold 213, and of course the Windows Phone. The hardware series telling us mostly about the main CPU chip and the baseband. Usually a way to hack the security mechanism of one phone would work for all the other phones of the same line. Just a few samples to help you to get around. And the BB5 category, we see the famous N95, which is what Nokia consider as a smartphone. Trust me, it ain't smart. First kosher line was made with 3 different models which all have the same solution. They are all DCT-4 in hardware, S40 in software. The first one was the ugly 1208, which is the shape of the candy bar. And second was 2680, which is also ugly, but it has a sliding keypad. And of course, the 2720, which is super ugly, but it can fold to hang up on people who are trying to sell you things. So step 1 of choosing a phone is checked. Now making it kosher. At first we turned to Nokia to ask them if they can make a kosher firmware for us. And their answer was no. But we won't sue you if you did. That's good enough. Also, we'll just have to patch the firmware ourselves. So here's how the Nokia phone firmware goes by. It goes with, it's made from 3 different files, 3 important flashable parts. The first one is the MCUSW, which is the binary that makes the OS, including web browser and a few other things. MCU stands for Master Control Unit, and that's the most important part, the most important flashable part. Then there's the PPM, which is something like a resource file with tables of strings, pictures, and animations. It stands for post-programmable memory, and this is what needs to be flashed in order to change the language of the phone, to adapt it to a different country. And Third, there's the image file, sometimes called content file or operators file. This is usually, but not always, a FAT16 image wrapped in some Nokia headers. This file contains things like the Java apps, ringtones, more pictures, many configuration files, and more. Beside all of that, the phone comes with pre-flashed with some code that is unflashable, that implements the basic flashing functionalities, a security mechanism, and part of the baseband. And we don't have the binary for it. So why would Nokia care to protect the phone from patching? It's because in some cases, such as in the DC4 series, the MCSW contains the code that implements the SIM lock, which is this annoying thing that providers put on the phone in order to make the phone works only with their SIM cards. The IMEI can be changed if you manage to patch the MCU. It can also make a spy phone from the phone using some patching, or it can make, or you will be able to make modding of the phone that Nokia don't like you to have. How to get those files? It's pretty simple. Just Google it. Most of the links you'll find online are linked to the Nokia servers. They serve those files for all the providers to have. But they won't let you enumerate those files. They won't let you search for those files. Therefore, you have to find links at other websites. Putting the files on the phone, putting the firmware files on the phone is a bit more tricky. There are about 3 common ways to do so. The Phoenix, a box, or in some new models, plain USB cable, combined with the right software, of course. The Phoenix, or as some people call it, the Phone X, is the Nokia standard way to flash a phone. This is what they give to the providers. It's pretty easy to find the software. It's a bit more tricky to find the hardware that comes along. If you're not a provider, it would be hard for you to get one. Then there's the box. Name box comes from these old days where back at the 80s and early 90s, where there were all kinds of boxes with funny names such as the blue box, orange box, and so on. These boxes were used to hack the public telephone networks. Does that tell anything to anyone here? No, raise your hand. Okay. Yeah. These boxes were, sorry. Anyhow, these days the boxes are what people use to flash a new firmware to the phone, or to break the SIM lock, or do different kinds of modding to the phones. In the picture you can see a small sample like the ATF box, Cyclone box, Jack box. Every box is made by a different group of, I don't know, call it hackers or whatever. And I own all of them, and all the ones in the picture. I have one right here. To connect the box to the phone, you need a special cable for that. That connects to the box on one side and the phone on the other side. The cable is known as a F-bus cable. Is usually referred to as a F-bus cable because usually the protocol that is used is F-bus, stands for fast bus. It's quite similar to RS-232. But sometimes it is simply RS-232, and sometimes it's USB. But the cable is always called F-bus cable. The cable connects to the phone somewhere at the back, usually near the SIM card, where the SIM card is. And on some newer models, you can simply use a USB cable and the right software. So at this point, we have a phone. We have the firmware files, and we have a way to put the firmware files on the phone. Now all we have to do is to patch those files in order to make a kosher firmware. At first glance, the file format seems to be very simple. After a short meaningless header, all the data is encoded in chunks in the form of type, address, that's the address that the data is logged to, length, header checksum, and data source sum, followed by the data itself. Simple indeed. Yes? Opening this packing reveals a new problem. Everything that follows offset 84 seems to be random data. The gray area in this picture is not really there. It's just a gap between two data chunks that I filled with Fs. I searched for it online, and indeed people in various GSM forums seem to say that everything that follows offset 84 is obfuscated in some way. One very special post that I found by a guy who calls himself Gego and his friend Knock5Rev seemed to reveal a bit more than the others. These two brilliant guys disclose everything there is to know about this obfuscation, and they wrote that they recover it by simply staring at the bits for 2 months, and they did it just because it was fun. Yeah, I think it sounds fun. And most important, they published the source code for free. Thanks a lot, guys. It was very helpful. I made a poor schematics of it to see how the recovery was done, but to be honest, it just confused me more. Hardcore black box reverse engineering is hard, man. Anyhow, after de-obfuscating the code, something that is less random is revealed. Few attempts with IDA. You all know IDA, right? Does anyone here doesn't know what IDA is? Okay. A few attempts with IDA and big Indian ARM code is revealed. We know where the binary is loaded to because it's in the headers, we know it's ARM because most phones are ARM, and because some documents says it's ARM. But if we were not able to find this information, just a few attempts with IDA will solve this mystery. And that's because we know where the data is loaded to. A few Python scripts later, I had a system to unpack, de-obfuscate, patch, re-obfuscate, and repack the firmware. And all I got is 2 different kinds of results. Result number 1, contact service error. I tried to contact service, they didn't know anything about that. Second, no signal error, meaning the phone functions perfectly, including Bluetooth and including playing those annoying ringtones, but it's not connecting to the GSM network, just as if I don't have a SIM card in it. This might sound what a kosher phone is supposed to be, but it's not exactly that. I went through the hard process of mapping the different results in the binary and came up with this. So after contacting the service 10,000 times, I had this kind of color-coded map of the different results. In black, bytes that don't do anything at all. In red, bytes that are making the contact service error, and in orange, the no signal error. Everything down there, from there down, is red. Now, note that these 2 bytes in the beginning just seem to be unrelated to the rest, and two bytes left all alone usually means 16-bit checksum. And indeed, that's a simple 16-bit checksum, just simply the sum of all the words of the binary. After fixing this error, after fixing this checksum, a new kind of error is emerged. A reset or reboot. When patching anything that comes after the first megabyte of code, the phone acts normally, including signal and everything, but it reboots itself after a few seconds. You won't even get to make one phone call with that. Patching anything that comes before the first, in the first megabyte, causing the first error, the no signal error. I guess at this point, I guess that someone is really trying to test my faith on it. We are left with 2 types of errors that are probably caused by 2 different kinds of checks. So at this point, we had to dive a bit deeper and to reverse engineer it to find more information about the checks. We get a fair understanding of the memory map from the headers of the files and from one leaked firmware with debug symbols, but the leak is quite old and it's not containing the first 200K of the binary, which is a bit strange. But it gives us quite some information about the memory regions. The device has a flat memory model, meaning any code can access everything by its address. Combining the information from the leak, a little bit of the reverse engineering, and parsing of the different files, I came up with this map. The understanding of the secure ROM area comes from reverse engineering. We saw some very special calls to functions at this area. Moreover, any attempt to read data from the secure ROM got us only zeros. It seems like the data fetching from this area is disabled by hardware. Like, not even the secure ROM can read data from the secure ROM area. It can only be executed. Besides that, we knew very little about this part as we didn't have the binary. Oops. In the first megabyte, we found this call to the secure ROM area. We guessed that this is the function that validates the first megabyte of code and activates the GSM if the validation succeeds. But at this point, we couldn't check this guess in any way. One interesting fact about this hardware, which is not that important for us, but it's still very interesting to know, is that this code gets one argument in our 0 that refers to some memory in address 9 million. But we don't know anything about address 9 million. We assume there's nothing there. What happens here is that this reference is actually to address 1 million, and the 8 million bit is just a flag that tells the hardware not to deobfuscate the data, that same obfuscation we saw earlier. Meaning any address that is accessed with the 8 million bit set is accessed as is, and not going through the DCT4 obfuscation we saw earlier. It seems like at this point it's going to be hard to research the secure ROM, so let's take a look at the validation of the rest of the code that is invoked from the first megabyte. We concluded that the first megabyte is a different kind of validation, and in the first megabyte, another validation is implemented that validates the rest of the binary, meaning the secure ROM validates the first megabyte, activates the GSM, the first megabyte validates the rest of the code. Pretty simple. If the first megabyte check fails, we get no signal. If the second check fails, we get a reboot. The integrity check of the rest of the binary function looks like this. This part loads the information about where the data to validate starts, where does it end, and the expected SHA-1 result. Then it calls the hash init update and digest function to calculate the real SHA-1 of the data. The information is loaded from this area. The data to check is divided into 4 chunks, about 3.5 megabytes each. You can see that the first chunk starts exactly 1 megabyte from the beginning of the code. You see the end address and then the expected SHA-1 digest, right? The funny part is that if we patch something of the 4th chunk, we actually get more time to play with the phone before the reset comes, okay? The result is then compared with the expected digest, and if it doesn't match, the hash mismatch function is called, followed by the reset function. Now, the hash mismatch function has a long jump. This is the common way to implement long jump in ARM. The compiler put those kinds of jumps automatically if the function is too far away. But wait a minute. Look at the address. This function is found at the 5th megabyte of code, not in the first one. This function that handles the hash mismatch is itself checked by the same mechanism, meaning when the validation fails, it uses the code that it just failed to validate in order to tell the user that it failed to validate. So exploiting it, it's quite straightforward. Thanks. Exploiting it is just quite straightforward. Just patch this function not to go back to the place where it was called from, but to the place where the hash does match. Okay? I have proof of concept for that. Please don't crash. Okay. So here's a regular phone. If I type in the secret Nokia code star hash 0000 hash, I get the version of the phone. Now I connect this phone to my computer using the F-bus cable. Okay. This is the script in the system I wrote to patch the firmware. As you can see, that just a simple patch of the secret code, and then the patch for changing the return address of the hash mismatch function. This is running the scripts to generate the new flash file. Now putting the flash on the phone, flashing the phone using this advanced turbo flasher software. It goes with those strange names for the boxes. Okay, that takes some time to flash the phones. Now where the phone is kosher, so you need the keeper. It's sort of kosher. It started at Yamaka. Now I show you that the phone still functions, and I type in the original code. Nothing happens because we changed the code. Now we type the new code, and I get the version of the phone. Now I still have to show you that it still get a signal for the phone. The first megabyte check also is done right. And it's now kosher, so I get a phone call from God. Okay. But if it's not enough, there's also a method to overcome the first megabyte validation. Now, with this method, we can patch anything that comes after the first megabyte of code. The way to overcome the first megabyte validation was first found by Gego and his friend Krisha. It's much harder and requires more time and effort to implement, but it will allow you to patch the first megabyte. The way to do it is to patch the timer interrupt code and make it jump as often as possible. In the timer interrupt, we simply dump the entire CPU state, meaning all the registers values. We dumped it to either the Bluetooth or to a file that we will read later, or simply to the screen. And then we invoke the first megabyte check, the secure ROM. After that, we would have a long log of all the CPU states during the execution of the first megabyte. This log can be used to recover the algorithm that was executed at that time. This is a fake data to help you just to understand the technique. I won't get into too much details because I saw there's a presentation about something just like that in this conference. But you can see that just from you can see the difference between the first and the second state. You can guess that the opcode was add R1 to R2 and put the result in R0. So at this point, we have two ways to overcome the firmware protection. We have a system of Python script to set the patches. Now we just need to write the modifications. I won't get through all the ways to reverse engineer this code. It has too many different kinds of menu systems and implementations, and we had to patch most of them because menus are the most crucial things we had to change. But here's a sample. Think of how would you disable the internet for sure with as little effort as possible. Some people might say that you'll search for the TCP implementation and patch that out, or simply look for the routing tables or patch that, but it all takes too much time. What we did is simply we search for everywhere in the binary where it says get we changed that to bet, and no web server will ever answer this phone again. Just to be extra careful, we changed post to most, and remember that the internet for those phones is just web browser. And we also removed the web browser from all the menus just to be extra sure if someone finds a really nasty way to get to the web browser, it won't work. Some of the patches are down in hardware. For instance, to make sure that no one would simply reflash the phone back to a non-kosher version, we cut the data pins of the USB or FBus or whatever it is and put epoxy on top. It's not 100% proof, but it certainly takes more time and effort than buying a new phone. Remember, those phones are very cheap. Okay, I had quite a few bugs on the way. For instance, at some point, I accidentally patched something of the first megabyte. I checked the patch. It seemed to be right and doing exactly what I was expecting it to do. But I didn't notice that the phone does not communicate with anything anymore because most of my development I did without a SIM card in the phone. Long story short, we almost started selling phones that cannot make any phone calls. FM radio was a funny one. We disabled it simply by removing it from all the menus. But apparently, people with lots of free time found that they can set alarm clock to use not a ringtone, but FM radio. So we fixed that, and we now also removed the chip that responsible for FM radio. Let them try to overcome that. One last interesting bug add is that, again, people with lots of free time, they found that there's this option for factory reset, just a quick way to remove all your contacts and reset back to defaults. We left this option on the phone. Someone found that if you go through a factory reset and remove the battery on the exactly right time, some configuration file is miswritten, and the next time the phone starts, it fails to read this file, and it falls back to much a simpler version, which have some unkosher things on it. That actually made me appreciate Nokia even more, because not only they make phones that are unbreakable by hardware, they make phones that are unbreakable by software. Good job, Nokia. BB5. I'm sorry we don't have time for it, so we'll skip straight to the next model, which is the 208 assaf phone. This one has WhatsApp, Facebook, Twitter, and the whole shebang. It uses modern trust chain for firmware check using RSA 1024 and SHA-1, and I don't have exploit for it yet. Hopefully, I'll find something someday. So with no other choice, we had to focus our work on the only part that is not protected, which is the FAT16 image file. In the image file, there are many configuration files that can custom almost any menu in the phone. So removing of many features is possible simply by making it inaccessible. Removing of games and putting our Jewish calendar is also possible from this file, but disabling sending and receiving SMS is a bit more tricky. How can we block the SMS and MMS if we have no control over the OS? At first, we have tried abusing the FAT16 format in various ways. Apparently, you can make hard links in FAT16, and the format supports that, but it's funny to see what OS would do with that, because FAT16 is not supposed to support that. And you can actually, nothing actually is stopping you from making two files with the same name, and or folders with the same name. But at the end, the thing that worked best for us was to find where the SMS are written to, delete that folder, and create a system read-only file with the same name. This way, the phone, when the next time the phone tries to write an SMS or read an SMS, it fails to access the destination folder. And it happens in much lower level than where the SMS logic is implemented. We wrote a script for manipulating FAT16 and releasing that along with all the other scripts for kosher, for the entire koshering system. Now we have just about 10 seconds left, no, a bit more. So we'll go through making the Samsung Kosher Phone in 3 easy steps. Now if you have a Samsung Kosher Phone, you simply get the firmware, you patch the firmware, and you put the firmware back on the phone. If it's hard for you to find where to patch, Samsung are keep leaking binaries with debug symbols everywhere. The only thing that might be a bit hard for you is that they have a very strange format for pictures and ringtones, but they also leak the tools to make those files. The thing is that it's that easy to make Samsung Kosher phones that, Samsung actually did it by themselves. They let the group that is responsible for the localization to make the modification for the phone. So we had less work there. I'm releasing everything but the koshering scripts, because I still do just a little money out of it once in a while. But the system can be used in order to research firmwares, Nokia firmwares, in order to make changes to them, to start to have basic research of the baseband or various other things, and create your own cool modding. I want to thank all the great guys that helped me in making this project. All the 2 friends that worked very closely with me on this project, they prefer to stay anonymous. A few guys that presented here last year, and of course Gego, Krishan, and Knock 5 Rev, and all the good guys from the GSM forums. Travis Goodspeed for helping me spread the word, and my wife and my daughter for stress testing the hardware. Thank you.